Right. Good, good, good. I like this. And then the last thing I need to do is just get over to your computers, maybe take control here. I'll probably have to turn this off if more people show up here. So be ready for that. Yeah, okay, good. So here I am with my worksheet. This one next, yes, hex head bolt. So let me see what the data is we have for this. This hex head cap screw. This will be great. Oh, this is my cheat sheet. Whoops. There's all of the answers we need. Quick. Yeah, it'll be recorded for you. So just pause the recording there. Can double check. I will post like the answers to these like I could definitely post up the tolerances one from last week. I'll probably always do it like a week later and so definitely turn them in, kind of when they're due, ideally. But then I will post them for you to self-check them, but I'll still check them. So let's see. Got to do my major diameter here. So that's just going to be, this is a 1 inch. So that's just a 1 inch diameter, a 1-8, 1 inch. So it's just one. I'm in inches. The pitch of that, well, it's 8 threads per inch. So that's going to be a 1 divided by 8, which is something I've memorized, 0.125. 1/8 is 0.125. So that's one pitch. It's a big bolt. 1 inch, definitely a big bolt. Not as big to hold up the windmills, but it's still getting pretty big. Minor diameter. I'm going to do this little calculation real quick. It's going to be 1 minus some group of numbers here. 1.08. 25 times a pitch, which is 0.125. So this is my minor diameter, 8647, I'm going to say 0.8647. That's just me using that little this little minor diameter equation. So I'm going to put this in. Yeah, 8647, is that what I said? 8647. Double check myself. 8647. Yes, love it. To 4 decimal places. I'm just rounding it. Width across the flats. Okay. Well, I don't know. I'm going to pull up my appendix B. So I have it up. That says appendix C, but that's just in the middle of appendix B. So appendix B, pretty soon off the start, I think, is our hex cap. Yeah, it's like the third sheet in from appendix B is going to be our hex cap screws or hex head bolts. That's a little bit, yeah. I think the assignment calls it a hex cap screw, doesn't it? This is me interested now. It's on the assignment sheet. Sorry, I'm thinking the reason why I'm calling it a cap screw, I think they call it that. Yes, a hex head cap screw, which is a total with a hex nut. And the hex nut's probably going to match the hex head bolt in a lot of ways. But let's see. Just in our appendix B, though, we call it a heavy or a hex bolt. Yes. So that's what's confusing. The names are interchangeable, though. The picture shows what I'm looking for. That's good. So an F is the width across the flat. So let me see what for an F dimension in a 1 inch. This row will handle 1 to 1 7/8. Yeah, so it's going to be 0.625 times the diameter plus a little bit here. They got a little fudge factor here, 0.062 added on. But otherwise, it's 0.625 times the diameter. So 0.625 times the diameter, which is just one, our major diameter, that is, which is 0.625 plus this extra here. That's head height. Sorry. Back up. I need to know that. What am I doing? I'm skipping. I'm not doing width across the flats. I'm doing the first column of calculations. We'll come back to this one. I'll go to the F is what I really need. What the F? It's this one. Okay. It's 1.5 times the diameter. That's even easier. 1.5 times diameter. Yes, love it. It's 1.5. So let's put that on my chart. 1.5 is the width across the flats. Then I can get the width across the corners. Maybe I don't necessarily need it. I probably only need one to draw it, but let's uh let's do this anyway. Width across the corners. That would be G. G, I get it this way. Width across the corners is, I need to know F, which is one, right? 1.5, sorry. 1.5 times this. Okay, that's a weird 1.5 times 1.1547. So this is the width across the corners. 1.7321, I'll say. 1.7321 to four decimal places. Sounds good. Check 1.7321. Yeah, that's good. And then head height is the one I was figuring. Yeah, so let's go back to that now. Now let's go back to this column here. That's the 0.625 times D plus 0.062. So I'll do that one now. 0.625 times the diameter, which is 1, so it's just 0.625 plus a little bit of a correction here, 0.062. So this is technically my head height, right? 687, 0.687. So I'll fill that out. Head diameter really doesn't apply. Like that's kind of confusing, but it's a hex head. So I think I just should have put NA here originally, or N/A, however I did it. However you want to do it, it's great. I definitely don't need to know head diameter. Length of threaded section. I did fully length. They're fully threaded on this one as well. McMaster Carr would tell me that it's 2.5 inches long would be a fully threaded bolt. There might not be an option to even not have it fully threaded. Remember, long bolts generally have the option. 2 inches, 2 inch long bolts are not. I wouldn't classify them as a very long bolt. Kind of short, especially these big diameters and only that long. It's actually a really short, stubby bolt, really, is what it is. But I mean, if that was 4 inches long, probably would have some partially threaded section. But and then the slot width and slot depth, those don't apply to us here. But so I think this is enough, and I think it's going to be. I think it's this one that we might have some missing data for, or it could be if I need the nut. Like so, I will bring up my like cheat sheet is my key here, and I'll just show you like let me decide if there was. Yeah, I I think this I should have added the so here's my key. I've added a couple of rows, and they really only apply for the nut size and height. It looks like they if I use Appendix B, they're just slightly different. Like it's not the exact like head height. Doesn't really apply to the nut kind of height of it. So I do feel like I need a couple of rows just to define the nut. And then and then I needed a couple more rows later for this other fastener. So right now I'm just going to add a couple rows and do the nut size and nut height. So you're just missing these rows, but it's going to be pretty easy to add to your table. It's an expandable little table here. So I'll go back to this. What I'm saying is we're missing a couple. I don't care where we put them. We could put them at the end of this, but yeah, your worksheet should be modifiable to add a row here or two. It's just a word type, when you hover on the side, you get a little expandable. So maybe I'll just do it. I think it doesn't matter where I add it. I think I added it before the slot width and slot depth that I used for that other fastener. So if I just click here and click here again, I can add myself a couple of rows that are already formatted this way. So what we really needed was a nut height and nut. What was it? Let me see what I was using for the way. Just the nut size and nut height. I guess the size is just because I need to know, but it's going to be the same nominal size or the size of the bolt. We would call that a 1 inch nut as well, as and we call this a 1 inch bolt. And that, of course, that's the major diameter when we say that. We don't call it out by the head size. We always call it by that diameter of the major diameters really are controlling size on our thread notes. So even on the nut size, it's just one. It's not something we have to figure. It's just actually just the nut size is one as well. But nut size, nut height. So let me type that into my missing nut size and the nut height. And we know, so these doesn't apply to these ones. So um, you can leave them blank or you can be like me. It's kind of a completist, not, but I'm kind of lazy. Like I don't, yeah, I do. It's just things that I'm particular about. You probably are not particular about, and the same can be said for some of the things you're particular about. I'm probably like, it doesn't matter to me. It's kind of how it is though. But this is going to be a one nut size, and the nut height. I don't know, so that's something I hope is. I think it's. I know it's in Appendix B. I think it's just below this. I think because it does relate to this kind of a fastener. A lot of times bolts will pass through something and then there'll be a nut on the other side to like just squish it. So it's a pretty common way to use a fastener. Even the other fasteners that we've drawn, they could sometimes be a through, they could go through something and have a nut on the other side too, or sometimes they could go into a tapped feature that's threaded. So, I mean, but here's my nut sheet here. So let's see. Interesting to me is they do show you kind of two different nuts is what they're showing. They call them like hex nuts and then the hex jam nuts maybe. Jam nuts are thinner, like in general, they are kind of made as a locking nut. So jam nuts are sometimes like kind of double nutted or you'll put a nut on and then you don't want that nut to like back off of under a load or whatever. And so they'll put a jam nut on. It almost holds the other nut in place is what we'd consider a jam nut. Uh, and so, I mean, not every application needs that. There would be an engineered reason why I would need to use a jam nut versus a regular nut, but they're thinner profile. They have like a thinner height essentially. And then not only that, but there's two different kinds of nuts shown here. One of them is kind of like a machine finish nut. Like I would call these like a general purpose nut, or kind of the one like either it's a jam nut that's kind of thin, or like this, where it's pretty much like a symmetrical looking part. I think we're probably used to looking at nuts that are mostly like, and that's why I call them probably the most common kind of nut we would use. I think these are also another real engineered specific design. The mating surface of the nut, it has the shoulder cut into it. And it's definitely like a more expensive nut for sure. But there would maybe be a reason why I'd want this, the mating surface and where that nut seats to like be machined, true, flat like this. So you will see these, and sometimes it's just sometimes the size, or maybe a metric nut is more like this, even though this is a standard chart. So just be aware that yeah, there's just different types and different costs associated with them. And in our case, I'm just going to draw the general one. So I'm going to use this as my as the thing that I'm going to draw. And really it's a symmetrical looking thing. So really when I draw one half of it, I'll be able to kind of mirror this over. So I can already visualize how I might draw this as just kind of in a vertical center line. Ours will be oriented horizontally, but I think I'll be able to kind of do like half that and mirror it is what I'm already thinking. So the H is the what I need is that height. And so the nut size D, hex thick nuts, hex nuts. I don't know. I don't love this categorizing that they've done here, but because they say hex jam nuts and then hex nuts this way, but they don't have like hex jam nuts. So, um, so let's see. Let's see. I think I'm using the thick ones. I don't know. Let me see what I used on mine. If I use the thick one, it would be, and I'm looking for H. Nut size D. This is kind of a weird chart to me a little bit. D is definitely the diameter, the major diameter of one. Here's 1 inch, the basic nut thickness, which they don't call it out as H. This is a weird chart for sure. They just say it's one, the basic nut thickness basic. That's weird. I'm trying to see where I pulled my data from. I may have pulled it from this one. I have a feeling I did do this one. If it's 3/4 to 1 1/8 size of nut, mine's a 1 inch, so it's in the middle of this range. It would be 0.875 times the times one minus this little bit. So this is a nut basic, plus it has an asterisk here. Oh yeah, what does that mean here? I don't know. this is a confusing table for sure. I definitely think they haven't done the best. And I have a I guess maybe I didn't analyze this as much as I did this year as last year, but I'm like I don't love the sheet because I should be looking for tables that are jam nuts and regular nuts, and I see they call them hex nuts and then thick nuts. I'm like, what the heck are you doing here? Like this is the re most ridiculous labeling here. I think that I use this one, whether that's right or wrong, I don't know. To me, the thicker one would be this, but then we also have this issue. So you could interpret this a number of different ways. I'll bring up my CAD drawing and see what I probably use the potentially this one. That would be 0.875 times 1. So that's 0.875. I'll bring up my calculator here. Probably be 0.875 times 1, which is 0.875, minus this little correction here, 0.016 minus 0.016. I'm pro on my key, I probably use 0.859 as the nut height here. 0.859. This one. But that could be confusing on whether or not is that the thickness of the jam nut or is that the thickness of the normal thick nut? And I'm like, well, I don't know. Their charts are kind of crap. So 0.859. Let me look at my other one. 0.859. So I interpreted it that way, but I agree. I mean, I when I look at this the second time coming through this, I'm like, well, I could choose this one and just call it one because the thick nut, maybe if you're looking at a picture for visualization, this one would seems like it would be the thick nut. Even this one could be. I would almost view my table shows me that both of these should be 1 inch in the H direction. I think the width across the flats, this should probably match the bolt head because usually it's the same tool on both ends. Not in all fasteners. There are some fasteners where they do put different nut. So it's like if you don't have the same tool to do both, you can have one or the other tool. I mean, there are some weird fasteners out there, but I'm thinking the F, according to this table, should match what my width across the flats were, which I think it was the same. It's 1.5 times D, it's 1.5. So I think in my table, the width across the flats is 1.5. So technically, I'm going to use the same width across the flats dimension to do the nut. Okay. Because the view looks like, I don't know if I don't have my course open that has a quick, but I will open it right now. Just to look at a quick reference real fast. The cheat sheet that's shown. Just go into my drawing. Right? Our drawing assignment here has a little cheat sheet to look, but I mean, so yeah, so that's what I was just nerding out over a little bit here is that's the width that could be misinterpreted, and it's really not critical to me, but and then what essentially when I draw this view of the hex, I mean, so the hex head bolt we're drawing front view, top and bottom, kind of to show the nut profile, but it's really going to be the same kind of profile as the top, other than I'm going to see the major and minor diameters, plus just it's going to look like the fasteners coming through here. So it's going to look like that. I argue that I've got some details missing here. Like I should see kind of two different diameters for this like thread relief. The reason why they do this at the end of these fasteners too is just so they'll be easier starting. The reason why they're chamfered like that at the base, like a pitch up, is just because otherwise, if they were just cut nice and square, they would actually be hard to start into the whatever they're mating with. So the nature of giving that relief is it actually makes it easier to start. You take that for granted if you haven't had to draw the particulars of it. But I feel like I'm missing a little bit of detail. I should see probably another circle here that shows that difference of that little relief there. Anyway, small detail, probably fix it this time around. And really, what I feel like is I could almost copy this and paste it down here and then just do a few other little circles that I'm going to have here. So, yeah, it's essentially just a copy paste of that. Okay, so let's go draw this now. I think I've got the data I need. Let's start this thing. I'll probably start it from get my construction layer turned on. I think I'll start it from the top view head, and I'm going to do probably one we don't use very often, which is this polygon command to me. This is a great use of a polygon command. It just wants to know what is the number of sides. Well, ours is a hex head. Hex is 6, so it's a 6-sided head. And then it wants to know where the center of that is. So I've put 6 in for the number of sides. This is where it's going to be centered. And then it's like, is it going to be inscribed in a circle or is it going to be circumscribed about a circle? So it's funny. I'm going to look at this little cheat sheet again and say, well, technically, I kind of want a circle. So I would say that it's circumscribed about a circle. It's on the outside. And so I'm not going to have my polygon be in the circle. You could technically do either way, but what I want to know is like maybe the head. I think it's going to ask me to kind of specify that by like the head, either radius or diameter. So I got to know like across the width across the flats here. Well, that was the whole width. So I might want to just, when I go to draw this polygon, I might say, well, let's half the width across the flats. Well, I've got that width across the flats is going to be 1.5. So I need to know what half of that is. 1.5 divided by 2. It's going to be 3/4 of an inch. It's just that I'm probably going to need this dimension to use this polygon because I'm going to say, well, it's going to be circumscribed about a circle. And how big is it? And I'm on the wrong layer all the way, but that's okay. But and so you can see that what you end up having control over is kind of, for one, the rotational direction of this thing, and the other is really whether it's inscribed or circumscribed. Probably doesn't matter as much as that I get this dimension correct on how the radius of it is, which is why I pulled up 0.75. Right? I said that it should be 0.75 in radius. Yeah, it's like using the opposite of rectangle. So rectangle is usually probably default shown in your draw command. Underneath there's that polygon, and then you enter the number of sides. Yeah, I think we've hardly used that, but which is what well, you could do either one. Technically, like I'll do the other one because I think that matters less than just making sure you get your number of sides right. 6 for sure. I'll just draw right here for just a second. And then I would say, well, this is my center of it. And then inscribed. Okay, what if it was inscribed? Well, it technically doesn't matter because well, you would need to know half of the distance. Okay, so here's the differences. Because it's drawing it by inscribed inside a circle, that means that the points of this polygon hit the circle circumference, right? That's the nature of the difference of those. And we're just covering that in math, which is why I'm kind of wigging out over it because like kind of matches our it's on this section of math. But you would have to know half of the distance across the points there, which you could figure. We have it in our chart, so we could draw it either way. You would just need to know half of the width across the corners. So if I was drawing it as the inscribed, I would have to do half of 1.7321 instead of half of 1.5. So I chose the easier one for real. I can do that in my head, but yeah, maybe I was being a little strategic, but I actually couldn't remember when I pulled that up if it was which way, but it is the points because it considers the points would hit the circle, whereas the other way considers like when you're circumscribed about a circle, it's that your flats of your polygon hit the sides, right? The edges, the sides of the sides of the polygon actually are the ones that contact the circumference of the circle. That's confusing, but it's good to, I mean, I think that's, anyway, that's why I also like this assignment. Is It's just that simple one-time use of that polygon command. It's interesting to see how they draw. So I'm going to leave the one I have. I just need to push it to the correct. See about that. So that's 1.5 inches across the flats. And I've oriented it this way just because I think I'm matching what they drew. I could orient it the other way and draw it the other way. Maybe this one's a little easier to draw this way, especially the front view is maybe a little easier this way than if I rotated it 90 degrees. But if you were drawing from scratch, you might not know which way you wanted to draw it, and you might put it in the other way. And technically, that wouldn't be wrong as long as you get your front view looking correct. So I'm going to go with this. I think it is the easier way to project the front view. But the other thing you would have is we generally draw the circle that they'd be circumscribed with it. It's because the head kind of breaks away. I think it's a minor detail. Like I wouldn't be surprised if we just could leave this like this, but technically I'm going to draw a circle radius here. And I'm just going to pull a circle that's like this because so that's just 1.5 inch diameter circle. It's funny that when we do a circuit, like I wished there was an option to, if you're doing one that's like circumscribed about the circle, I wish you could drop the circle with it, but it doesn't. It does the geometry that way, but otherwise it would look like this, circumscribed about a circle. I just add the circle later, and that's because that's kind of how the head would really look. Like if you look at a bull head, and I pass one around, but the corner, they kind of break away the corners. Like it kind of actually in this top view, this circular surface might be right at my eyeballs, but then to the points, they're just kind of broke away just a little bit. And it's really so it allows like tooling to be placed on it. It's almost like a relief for the tooling to slip over it. That's why we put a little bit of a relief kind of down and away from me from that circle, down and away to those points. It's a slight relief. It's not very much, kind of like this in a way of this third one we drew. Just a little bit of relief and allow over the easy. So another thing you probably could figure out. It was just a nice sharp cornered hexagon. The tooling, when I go to slip my tool over it, it hang up. We have to be really more precise when it puts the tool over it. With the relief, it can be a little lazier and it'll find its way in. The tool will find its way in. Especially up close, right? Like on your wrenches, you have a box stand and an open end. Yeah. When you try to slip over the box stand over, it's nice and fast and it has a relief in the head so that the box stand will slip over easy. If you're using the open end wrench, well then it slips off to the side pretty easy. Or if you're using the worst tool in the world, which is a crescent wrench, the adjustable wrench that does one size fits all, well, you're just gonna round off all the bolts, the points of it. I still use not good for high torque situations. It's handy to have in a toolbox for the multi-purpose Swiss Army. The Swiss Army. Okay. Move on. Let's project down. Do some- Yeah. And so I think I'm going to need to know the outer points, at least down to here. Maybe I'm not going to take this projection beyond down to the surface level that we have here. I think I'm gonna bring these points down. I think I'm gonna bring these front points down to what I have here is a foreshortened kind of surface, right? This is a foreshortened looking distance. And then this technically this one will be a true length distance here. I'll be looking right at one of the flats of this right there, true length, foreshortened, foreshortened. So I like that. Maybe that's all I need at the moment. I just need to know its head height. So maybe I'll draw this in and we'll kind of mess around with this. So let's do that head height. I think we have that on our chart. So I might offset. So if I think about this, I'm gonna just do a line that I can offset. It's a little short line, right? So I know that I'm gonna have a visible line from here to here. So I'm just gonna draw that in. And mostly because I want to use it to offset from my head height. And I'm gonna have that across the bottom of my bolt head anyway, just like we've had in pretty much every fastener. So, yep, with that line, I can offset by the head height. Like I say, there's just one way to see this, but you can do it many. Here's the head height right there, 0.687. So I'm going to offset that by 0.687. Offset 0.687. Enter. There's my head height at least. And now this is the trickery that they show us here in the book, which I wouldn't know this. I'd never probably drawn these myself until coming here. And I was like, oh, that's pretty interesting. It's kind of like a little like a pencil triangular hack here. And it's just a generic. So what we're gonna do is we're gonna draw that relief that I was just talking about. Instead of having a nice square top head, we actually have a little bit of a relief down to these points. And so when we draw that, it's kind of a particular way, but I'm going to show you on Appendix B some of the imagery I've showed clear down when I started adding stuff past appendix, like past this little drawing right here is out of your book 372. I know it's drawn horizontally, but essentially what's going on here is essentially what I want to do. I'm projecting the other way, but I'm projecting down. I've kind of drawn this in, but this is their little trick that they show how to do this. Well, if I move around to the right there. So I project this down. I have these sides. I have this kind of drawn in. And I have these drawn in. So how I get this actual like radius here that kind of shows that relief from the top of the bolt head or the screw head is going to be somehow I have these like lines this way, and then I'm able to kind of draw an arc from like a center point here. So what they do is they take from those points and they draw down what they say is a 60-degree included angle here. So I'm going to draw from those points down where they cross. I want to make a 60-degree included angle. And then from there is a center point that I can use to draw this arc. They continue this one clear down to the center of the fastener. And that allows us to draw this arc here. So let's see if we can kind of piece this together. I'm looking for the only thing that I really have to work with is I'm going to make this relief on a 60-degree angle. And really that might not be the exact way this head is designed, but it just kind of is a quick hack way to kind of show the relief that's in the top of this head. So I feel like it's not necessarily super accurate for the bolt itself, but it just is kind of a way to show that relief and be at least a little like visually looking correct for what the head of the bolt would look like. Whether it's completely accurate, nah, that's kind of arbitrary. It's kind of like, nah, we just want to show a relief. So I'm going to use this 60-degree included angle measurement. So I'm going to go back over here. What that means is I'm going to draw from these points. I'm just going to draw a line down here that's 60-degree included angle and these. And where they cross is kind of the center for an arc. So let's see what that looks like. Maybe I'll do this as construction material for sure. So from here down, I want to draw something at 60 degrees, which is cool because I have my snaps on that, right? So I'm over here on my track, my polar tracking here. I've got 60 degrees selected, so I can do this relatively easily. So there I am. Here's 30. Here's 60. If I do that, let's just check this though, right? I'm going to do this, but I just any length of line, I just want to be able to make sure they intersect like that. I'm just looking for like two at 60 like that. And then I should be able to measure this. This should be 60. If it's not, I just need to fix it, right? I drew two. But from there to there is 60 degrees, essentially. And I've just kind of drawn them long where they intersect. This kind of creates a center of arc. And so really I have this like arc center that I'll be able to draw in. One thing I'm going to do this though is I'm going to pull this one down. I'm going to stay on that degree, but I'm going to pull it along clear down in center of the fastener. This one that comes from the outside. And I end up making like a center cross here, and I end up making kind of a center cross here for this arc here. I'm going to do the same thing on this side. Maybe I'll pull this one clear down and across, right? Mostly I'm looking to snap at the correct degree. And then I'm going to do this one. It's going to cross. I could trim these, but they're just construction, so they're just crossing. If you want to trim that, you can. I just made them so I can see the intersection easy. And then let's go back and look at my little appendix here and see. So I feel like I've got those pretty good. And what's that radius? What's that radius? They don't really give us a radius there, right? I'm looking probably to use there's definitely a radius. I think I would have just used, well, I think I just used, let me see. Over here. I think I just pull a circle, and this is going to be my radius right here. Just like that. So I'm using from that point up to where it actually hits the top surface. And what that does is it intersects right here and right here. So I want this arc to kind of be from not to that, but to right there. So what I've got, if I haven't drawn this yet, if I go to visible to make this a little clearer, even though I'm going to have to trim this, this would be as if I didn't put any relief on the bolt head. It would just look like this nice, it would look like a rectangle here, right? Like if I'm putting visible lines in over this. And then I would have visible lines here. Because that's where those surfaces are different, right? So I need to make sure I draw this all the way. So if I was just drawing it like that, but that's not exactly accurate, I'm showing that relief. And so what I'm going to trace, I'll just trace over this with that 3-point arc that we like to use here. So here's one point. Here's like center point, this quadrant. Here's the other point here. Yeah, so that's really what that looks like. And then this is going to it's going to kind of trim out here, but it's going to leave it here because I'm looking at, and then I'm going to have this other surface here, this other arc. So I can just copy this little arc I just drew. By this point, sure. Drag it over here. Oh, I haven't, I could keep that. I could do this. I really don't even have to do that circle, or I could do my circle. I'll just do it. Or you could mirror across. Like I'm doing stuff that I probably could mirror, but that's okay. I'll just keep doing it this way. Here's that other construction circle there. And essentially now I'm just copying this piece over. Or I could trace over too, but it really should match if I do that too. Okay. And then from that point, it comes up and hits that and then down to there. So I could draw that as probably a 3-point arc too, right? Like if you like that 3-point arc. So we used yesterday. We loved it. It does like that. I'm on the wrong layer, so I'll push that to this layer. Okay, so I think that is it. I could have drawn that arc too using the same like circle. This is the center of that arc though, clear here. And then this is what would pull to there. And it looks like it's actually slightly different. That's because I think it's kind of by hand here, and I'm gonna get a little bit of an inaccuracy here. So I ended up using from point to point with that arc that I did more than that circle. Otherwise, I'm gonna have to pull those kind of together. I think so, because this is kind of just a hack method to show the relief. And so I'm gonna turn this off for a minute. Let me go to visible object, turn this off. So that's pretty close to what it would look like, other than I'm going to trim some of this out. This surface would all be blended here. And so this technically I wouldn't have that like that. And then I would actually show this trimmed like this. And this would trim because when I would truly look at the front surface of that and it's that is what shows that relief. And then I would have this little thing trimmed out here. It's a little hack method. It's not absolutely correct, but it gives me the gist of, oh, yeah, that allows you to slip a tool over that pretty easily, and it lines itself to a tool real easy. So nice. Now let's do the major minor diameter and the length of that thing, at least finish off the bolt. And then we can worry about the nuts here. But what I'm saying is I think I'm going to just copy this and copy some of this down for the bolt. And so, or for the nut, sorry. But I think I'll finish the Nathan. I'll jump off here for a minute. But I'm going to finish the major minor diameter of this bolt here. So I'll leave up my construction layer for a minute. I think when I was doing that, I was putting in a center line. So from here, go from here down. It's not any something like that, that I can offset. So it's a 1 inch major diameter bolt. So I'm going to offset that. Five. Half of 1 inch is 0.5. And so this will be the major diameter right there, there. We have the diameter. Now show properties of everything with my visible layer. So that's my visible bolt for the diameter. The minor diameter. Minor diameter is like 647. You know what half of that is? 8647, half of that. So let's do that here. I'll pull up my calculator here. 0.8647 divided by 2. That's my minor diameter radius, essentially. My minor radius. I have 43235.43235. I'm gonna come in here and set that up 0.43235. It's out to 5 decimal places. That's it for me. So that something that's hidden line. We just need to know the length of those. So the length given is the length from the underside of head. And in this case, it matches the lengths of this one and this one. They're really driven from that surface underside of the head down. So I think it's 2 and I'll try it with 2.5 inches down. So I'll jump back over to the swing. Average long on this one. Oh, sorry. Yeah. Yeah, so I'm gonna offset this in for that. So 3.5. I've got this little piece that I'm gonna offset. Very familiar. You can extend all these before you're gonna be true. Actually. So now I want to offset that a pinch, right? So it's gonna be like one pitch for that relief start thread. One pitch, I think I already got number 0.125 because it is 1 inch bolt. Force that's bridge, 1 divided by 8 is 0.125. I need to check that again. I think I fat fingered that offset. Yeah, 0.125, not 1,253, like that. I'm gonna do the same. I'm gonna put back on my 45-degree drawing. 45. I'm gonna put these at 45s as well. Not a center line though. I'll do the right layer. Out loud. There we go. There's my 45. Good. There's where it intersects. Here. Trim now. Opposite of extend. Trim. Let's trim this out. Trim this. Nice. Finish there. Now we just need a nut on that thing and a nut view there. Um, so I think what I'm going to do is I think I'll probably place this for my nut here. I might place it about the same distance away as my top view to the front view is. I'm going to do the bottom view of that nut, and I'll just place it away the same distance here. So maybe I'll make. Technically, I need to fix my construction line here. Fix that real quick. Or sorry, my center line. Okay, there's the actual center line. Yeah, so let's make I don't know, maybe I'll make something here. I'll trace it. I'll trace a construction line over my other construction line. What I want to know is how far this is. Maybe I'm coming up with just a symmetrical plan here that this is 0.813 away. I'm just going to do that. I'm going to place the view at the bottom this same space away. 0.813 is mine. I think probably everybody's is that way because really the assignment sheet gave me that distance between those two views. I don't know if it gives me the distance in the bottom view. Let me look real quick just for my own. Can't remember if it gave me a dimension there, if I'm just going to match. I don't think it does, right? It gave me this dimension here, and that's what I drew mine to. I used all these dimensions as well. It just doesn't give me a dimension here, and maybe theirs looks a little closer than mine. I'm just going to put the same distance away here as here for no real reason, just so I know I have enough room, really is it. So I have that dimension up as 0.813, 0.813. Yeah, sure. So I'm just going to draw a construction line. Not that it's super critical, but I'm going to draw it from here down 0.813. So it's a line over a line, but it's just construction work, and I should be able to see it or snap on it, or it should have an endpoint. There it is. So I'm going to copy this down to that view. So I'm going to come in here and copy all this. I think it's just two selections, right? Yeah. So copy that, copy the polygon and this the circumscribed circle and polygon here. I'm gonna actually copy them by this point here though, because that's how far away I want to be down here, right? That's what my little end point of my line is somewhere. There it is. There's a midpoint there too. It would look like a triangle, right? That's the midpoint of that line. There's the end point. Okay, so now my bottom view is pretty much spaced the same distance away as my top view was from my front view. And I needed all that anyway, because when I'm looking at the bottom of the nut, that's what it looks like. It would look kind of like, because I'm doing that nut that's kind of symmetrical from our appendix. So I'm going to come back and refer to this nut page here. That's the metric ones. The standard ones had a few more different pictures right there. I'm going to draw my nut like this, using that height that we got from here. Whether you use this chart, used one as the nut height, is fine with me. I ended up using this chart and came up with that kind of oddball nut height. So I'll use that, but either one to me would be correct because this isn't the best chart. So I'll use the harder number instead of just one. Why? I don't know. Make my life difficult. But that's going to be what happens here. For here, I can just kind of finish the bottom view, and what I would show, even if I didn't have that cheat sheet to look at, I would show the major and the minor diameter of this. So I can project those down and draw those as a circle, major and minor diameter. And then I might even show this relief here, right? I would show the difference kind of in like if I was looking at the bottom of that, I would probably see kind of the major diameter, and I would see maybe this minor di or this the relief diameter there, which isn't totally necessarily correct, right? That's just me doing like a 45 nip at the end with a pitch up. So it's kind of like the bolt head. It's not exactly probably matching what a 1 inch bolt head looks like, but it gives me the gist of it. So what I've got is I want to know kind of where my center of this would be. So I could do a center across here just to give myself a center cross, something to snap to here. I technically had a geometric center that I could snap to there too. So I don't really need a center line there, but let's do the major and minor diameter. So I'll draw this one as I'll draw it as a here, and maybe before I do that I'll project mine down. That's how I'll do mine. I'll just project the major diameter down across this thing. Um, so there's the major diameter. I only really need one to project, but I'll do the whole. And then there's the minor diameters here. Yeah, this is minor diameter. It's going to look like, yeah, let's see here. It's going to look like, just so happens that that geometry, it looks like to me, lines up with a point over here. I'm going to double check that. It may or may not. That's just purely luck, I think. That it's not exactly. Oh yeah, yeah, good, good. Because I wondered, I was like, there shouldn't be a reason why that would line up. It just if it did, it would be fate, and I would stop drawing now and be like, that's amazing. If yours lines up, well, it's slightly, yeah. I wouldn't freak out yet because yeah, and the only difference is I keep mine on. I don't never draw without it. It's just that I like, I think I explained this. I like this one better because it gives me 90s and 180s still, right? So I still technically feel like I have them. But yes, if you love ortho mode, it has bit me though. You've watched me actually draw things. If I would have used ortho mode, it would have saved me. So I can't even teach myself. But let's see. I need the diameter though. This is the major diameter would look like that, right? Then I would have this minor diameter would look like this. This would be this bolt coming through there. And so what would I see? Well, I would actually see yeah, I would just see the major one coming through as a visible line. Maybe one of these is going to be hidden line. Yeah, is that right? I would almost think the major would be hidden and the minor I might see, but that's not necessarily true. What did I do on my other one? I actually like when I go like yeah, I actually used this sheet when I did. Yeah. Let me check here. Technically, when I drew mine, I ended up drawing my major diameter is hidden. That could be arguable. I guess what I'm okay, so what I'm thinking of here, think of this, and this is why I've drawn it this way, is I'm almost viewing that it's not drawn. It's not drawn with it like showing the bolt coming through it, I guess. Like it's showing the nut without the bolt going through it, which that's confusing. Um, yeah, correct. Like this would be the way to show the nut if I didn't have a bolt coming through it. So maybe I'm going to just keep it like that. And the way you would, and because it's just kind of a study of as I was just looking at a nut that didn't have the bolt through it, it would look like what I've got drawn here. You would see the minor diameter as the visible line, and the major diameter, because those are the internal threads, would be a hidden line. So this is technically this bottom view is of just the nut without the bolt going through it. And that's not I mean I didn't really catch that till this year. I don't remember like thinking about that last year. So It made me think about that when I was like, if I really was looking at a bottom view, I would kind of see both like this in a way, or maybe I would actually not have, it would almost be opposite where I would see a visible line as the bolt coming through. And maybe I would show this as a hidden line because it's just that one. Yeah, if I, well, you'd be showing the minor diameter, like, you'd be showing kind of the minor diameter of the bolt is what that might, but that's kind of confusing, right? A little bit, but, well, it's weird. I mean, I definitely wouldn't have the looking at the bottom of the bolt, you wouldn't see the minor diameters as visible, I don't think. They would be kind of they'd kind of be blocked by the major diameter. The outside thread would kind of block your view of the inside thread. If the peak of the thread would block your view of the root of the that's what this is. This is peak of thread of the screw. Yeah, and technically, like if I'm thinking this is a true bottom view of a nut with a bolt going through it, I think it would look like this actually. However, I still wouldn't be done. I would want to project this down. So, and I only really need one of them, but essentially I can do both like I did the other side. I'd want to project these down because this would also be a visible circle on the bottom of my, because I'm really showing the details of think of it, what I'm looking at here is actually I'm not even looking at the nut here in a way, I don't think. Yeah, I'm actually looking more, I'm looking at, yeah, mostly I'm looking at this is the bottom view of the assembly. Like technically the way I've shown you that, but yeah, I'm kind of thinking about it a little bit different that I would have bottom view of the assembly might look more like this. Yeah. That seem right? Because this is actually major diameter bolt. This would be kind of the minor diameter bolt, and this is the kind of the relief in the bottom of the bolt, essentially. So all those lines are actually this screw here, and they're all just projected down from it. That would be confusing for sure. If I drew, so I'm already thinking of it being, that there's a nut on there that I'm still not showing. Let's go draw that now. But yes, so this is how I might draw it this time around, thinking of it as being the assembly and not like this, where I feel like I'm thinking of it as like a nut off of the assembly, and it would be think of those opposite. Yeah, I love that idea because it's kind of the difference of min and max material, or least and maximum material condition and least material condition. Just kind of that concept there. But I feel like this is technically not the view that I would see if I was really looking at the bottom of this assembly. Yeah, exactly right. So let's make it so that makes sense now because I don't have that in my assembly. So let's do that. And I think I did that anywhere on here. I don't think there's a particular length that I put this, but what I did is I actually just I'm going to copy this. So maybe I'll just set an arbitrary position of where that is. I do know that head height though. Like that was one thing that I did figure from my the head height here. And I kind of chose, I don't know, this is what was confusing about this for those who come in just a little bit is why I sat here and like nerded out over this is that, jam nuts are thin nuts. Regular nuts are kind of a thicker nut. But they don't call this table like jam nut, and they don't call this one just like regular nut. They call it hex nuts, then thick nuts. And I'm like, I don't understand. This table drives me crazy. So I chose to just use this first row to figure my head height right here. If you chose this one down here for 1 inch and it was just a 1 inch, I would be fine because that might be the one that's the regular nut, which I'm trying to draw this. I'm not going to draw the one with the kind of machine finished shoulder, like a more expensive nut. I'm going to draw a common nut like this. And what I'm going to do is what I told everybody I'm going to say. I'm going to mirror what I did on my hex head, and I'm going to mirror it down here. But so I'm going to set this width here, which mine is this oddball one because I use this row for my nut thickness essentially, or the height of this. So that's what I have in my particular worksheet table. If I open down, scroll down to where I did my math here. And then I added a couple rows because my table didn't have nut size and nut height, which I kind of need here. So there's my nut height. It's 8.59, the 0.859. So I'm gonna remember that, and I'm gonna come back here and say, well, I'll just draw it anywhere. I don't care where that nut is on here, just as long as I have enough room to draw it. So maybe I'll just pick a line, any line. I'm gonna pick a construction line crossed here. Do I want to draw it here? Sure. I could use this as I could use that point. I could use a midpoint. Maybe I'll do that. Which I'm gonna say, I'm gonna draw my nut. I'm gonna offset this, the nut thing. See, so or the nut height here. So that's a 0.87, what is it? 0.85. So I'm offsetting this 0.85. It's and that's where my nut will be drawn on. It could be anywhere on this, as long as it doesn't fall off, fall off there. We want to show it protruding through the nut. Or what we'd say is fastener is proud of the nut. That's a weird term, right? But technically, the way like a fasteners are designed is they um, however the nut and fastener relationship is kind of critical. You want the fastener to pass through the nut a couple of threads. You do not like it's not a correct way to use a nut and a screw if it doesn't go through the nut all the way. Whether it's a thin nut or a thick nut, you always want it to what we say is called be proud of the nut, go through it. Or if you think of it projecting through it. If your combination of what you're sandwiching and you're bolting it together and it doesn't go through the nut all the way, you're not using, it's just not a good engineered design. And then you don't want it to be like excessively long, but that's just a waste of material. You're if the fastener length is way past the nut, well then it's a bad like combination of parts because they don't do any good going way past. But we like them to be proud. So make your fastener proud of the. That's my advice. And it matters. How much? Well, that's a couple of pictures of what would be great. But sometimes there's always like, well, depending on what you're sandwiching between, sometimes you have to make some, sometimes it'll be through there 4, 5, 6 threads. Okay, that's the relationship of what you were sandwiching plus the length of bolts that were available to you. There's going to be some very, you just always don't want to pick a relationship where it doesn't come through the net. That'll be a poor relationship. Okay, here we go. So what I'm going to do is this is where this is going to be. So I'm going to take some of this. What do I got? I'm going to see how this thing is segmented. Got that piece, that piece. I've got that arc. I've got this side here. So maybe what I'm going to do, the way I've drawn it, I'm going to copy. Yeah, dude, totally do that. Yeah, this is the pieces I want, right? That. And then I'm going to copy those from here. I'm gonna draw them down just here. It's kind of like one half my nut. Right? I'm going to mirror that over a center line that doesn't exist yet, but if I can draw a center line between these two, I can just mirror that, and then I can just connect the line. That'll be my nut. So kind of pretty simple. Once I draw in the head, I think I have the information. So I don't know what I need is just some construction material here, maybe anywhere. I'm just going to draw it right over the center line here. The only reason I'm drawing that is because I have like a midpoint now, here, right? And that's all I really need. I don't even need to draw a line in the center. You just say, well, I'm just going to mirror this. And if it's all joined, again, you saved yourself time right here, right? I'm going to select 4 pieces here. And I'm going to use this as my mirror. Not going to erase my source. And then I'm just going to hook those points together. From here to here would be one. And then it would be from here. It's not necessarily a line, like I'm going to be careful here. I don't think there's any relationship between the minor diameter and where that nut, or where the bolt head edge is like this. So I'm not going to use, I want to make sure I could project that down is maybe what I would do is the safest way. I'll hook this one up here. For sure, it's just the outside. What I'm saying is just be careful if you want to construct a line down. Really where I should have a visible line is from here down and across that nut. I'll make sure I'm perpendicular, not flip into something there. I mean, it's like ever so slight, right? But there's a little difference in it. We'll do the same projection. This particular piece of geometry is it's just fraction of a fraction off. You'd never be able to tell. And since we're not drawing like super, it's not an actual part, it's just a representation of that. It wouldn't, probably I could have traced the hidden line. You would have never known the difference. It's not something that's truly being dimensioned, but where that would be is where it kind of crosses here. Should be there. That's good. It shows that that's where those two come together. And I guess I already had the information I needed, right? It was where those two come together. But I probably didn't need, probably didn't, I already had the, I already had these points right there. And when I knew them, I'll be waiting here there. Turn off my scripting. I just need to trim out some stuff now, right? So I wouldn't see this major, I wouldn't see the major diameter through there or here. I would see the nut itself, and I wouldn't see the major diameter here. That's kind of nut relief surface there. That. I wouldn't even see that hidden. I mean, I could keep the hidden line. It's kind of a hidden line. I can't remember if I kept it or not. They're slightly off each other, but I guess if it was a real, you could leave them or probably leave it. You probably won't be able to tell from my example what I did there. It's hard to tell because I bet you my visible line when I really go to a print is going to be a thicker than my hidden. I bet you it'll actually cover it based off line thickness. Where if I didn't trim the hidden, you probably wouldn't be able to see it. Maybe the only place you might see it is right here across this. But and I think it's okay to do that driven through there. I don't think there's a problem. It's just the way the line separates here doesn't really draw across. I think I'm not even like that. It's the nut on a bolt, and that's the bottom view. I'm going to add the center marks to them. So I'll definitely still do centers and marks. You can circle it inside that. Put this one too. Find the center marks. Oh, I guess it's for that. Bringing up my properties. View tab, properties panel. Get in there and manipulate these lengths. Nothing. I don't even need to do that. I've got those already lengthened over here for this match the property. This one, taking a quarter inches, stick too much. I think that's the hard one. We're in good shape. I know we're about out of time again, but I'm gonna finish though. I'm gonna finish this in the powder pin, and I got to finish my table and stuff on my actual drawing. So I've got some work to do. Let's do it. Come back on my construction layer. Yeah, for those of you that didn't see how I drew this, I did have like what all I did was I drew even draw that original CAD is. I just followed this procedure that's really, and that's why I put this in here is because it's just kind of a real simple page out of your book to use that here, right? Like I drew it in totally rectangular square because I actually drew the bolt head first in the top view and projected those points of the X head down to my front view. And so I had it as a rectangular looking bolt head and screw head, let's say, with where the points are. And so I had the four shortened surfaces and the true length surfaces here. And then I just used the 60-degree included angle concept from the points of that rectangle. I drew those down, so I created a 60-degree included angle, and where they cross essentially is where I was able to say, oh, that's like, and then I drew this 3-point arcs, point to point to point. And I did that again here because if you actually pull like circle here, it isn't quite the same, even though I did project this down the center. I technically didn't end up using this center. I just used from point to point to point to draw those three little arcs there. And then I trimmed my head so that it looks like how it does. So I feel like that's the trick of this here is just getting that initial bolt head done, showing the relief that allows the tooling to slip over that pretty easily, And I will just continue to draw this away. So let's go figure out some data for the last one, which is what it's called. I think I need a few more rows on my table though. So let me look at this is the socket head cap screw. So that's this one, socket head cap screw. So I've got all the data here. Let's just see what I'm missing a little bit. So I'll pull up my little cheat sheet here. But let me fill out what I've got. So I added 2 rows to my table for just the nut heights on that one. And so I marked NA on those. So your original worksheets won't have these 2 rows. I just added them, nut size, nut height. They didn't apply to anything but the one we just did. In this case, let me just go through here and just figure out this is a 1/2 inch 20 unified national fine fastener socket head cap screw. So the major diameter is going to be 1/2 inch. The pitch is going to be 1 divided by 20, right? 1 divided by 20 meters of wet. 1 divided by 20. 0.5 is the pitch. Pretty fine for that. Actually, that's 0.05. I'm saying that. Oh, it's 0.05 for the pitch. Minor diameter, I'll use the same. Strange movement. That's the diameter. So that'd be 0.5 minus. Sorry, I'm having a formula here. Diameter minus something. 1.085. I should have that number. Times a pitch. 8.05. Right? That should be 0.4459. I'll say I'll round that to 4. That's okay. So 0.4459. With the cross the flats and corners don't apply to this one. Head height will apply though. So I'll go over to my sheet. I think what I liked on this one, just for this particular fastener, zoom way out of my pencil. I think when I there are these kind, like if I go up in the appendix, this fastener is found here, there. Maybe this is symmetric. This that's the metric version. Up further is the standard version. Right there, right? I think I could find some of the stuff here. I'm not using F, which I think is it's the fillet little radius. I haven't been putting those in. I'm not worried about that. But technically, if you would grab one of these fasteners, there probably is a little relief to where the major diameter meets the underside of the bolt head. Sometimes they have a little bit of a radius there. That's what that's what that fillet and that F is kind of pointing out. Is it just a little contour? I haven't been drawing those on any of them. I'm not going to start making. So I think I could figure that out here. But what the problem with this was they didn't have any dimensional figures for what was going on with the tool input on this thing. So I'm gonna put that in though. So that's I think when I added this, let's go down to the add-on stuff. It might have everything we need actually just from one. I think I have one that's just socket head cap screws. There's that one. What's the page 23? I'll zoom out. I ended up using this chart. It was able to help me like lock in the size for the tool here for this hex. Maybe we'd call this like a socket head cap screw, like a. We wouldn't really call it a hex head, but you know. And you think of it like the tool you might be common to use this is maybe called an Allen wrench. Is what we would call the little hexagon shaped tool, the Allen wrenches. Some of them seem like you wouldn't be able to torque down very good with an Allen wrench, but they actually make Allen wrench type fittings that go on like ratchets, and you can actually torque them down pretty hard. So they are a good fasten and with high torque specs. But anyway, I think this thing had everything we need. So because its head height is H, my particular diameter is 1/2 inch. My major diameter is 1/2 inch. So the head diameter is, I'm probably going to need to know this stuff too. A is the head diameter. Head height is 1/2 inch, so it just matches the head. I'm sure this conflicts with the other chart above it. Like I said, depends on which fastener manufacturer you pull this data from. And old data sometimes a little bit outdated. Newer charts probably have the newer, this tooling gets modified from year to year, decade to decade. The size is slightly bigger. I'm going to use this half inch of the plant for the height. So I like that. Head diameter, I do need to know that. So I'm going to have to know. It's a round head. So that is A, right? Is a diameter is point, it's 3/4 inch. So that's head diameter. Oh, countersinking. Yeah, we don't need that. That's countersink involved in this fastener. So that's I did this one fully threaded too. I probably should just add it fully threaded to that. It's only a 2 inch long. Probably unlikely you're going to find one that's partially threaded that's only 2 inches. The slot width and slot depth, they don't apply here. It's not a, so I'm just going to say NA here. So I'll copy these. So I don't really have a slot width or a slot depth. But what I would be missing if I'm just looking at that, I have the diameter. I might not have, this is nice to know. This is maybe just the relief. So pretty common with these socket head, uh, these socket head cap screws. They also have a little chamfer relief here. Not that the tooling slips over that, but I think it's just to break up. This isn't a sharp corner on the finished look of that. That's why we have like a double looking visible line here in this top view. And we're going to recreate that as well. So I might want to know this S distance as maybe the head side height or something. So, and yeah, because they call it a side height there, and they give me that it's 0.45. So that's going to allow me to kind of draw the detail of this chin, that side head height. And then the rest is going to be other stuff I need. So I think I need I think what I'm lacking in my table is like a head side height, the hex size, so kind of the width across the flats of the tool input. And then T is the T, what is the engagement? Oh, the depth of that essentially. So I need to know how deep that goes into the fastener for the tool, which is pretty, they call it the key engagement. The key being the tool. I don't know if the key engagement's most obvious column heading, but that works for me. So I think I'm going to create 3 more rows on my chart that only apply to this particular fastener. So I'm going to go back here. And what you'll notice is I did that here. What did I add here? Well, I definitely didn't need the slot width and slot depth. We added the nut size and nut height to our one for this one. And then I'm going to add the internal hex across the flats and the internal hex drive. Yeah. The only thing I can see that I could add one more thing, and that's that head side height. Oh, maybe I do have it in my key, but I must not have it on yours. So let me look, see, I might add the head side height after the head height. So let me jump over to mine. The ones that you don't have, this one. Head height, I think I added this row here that didn't apply to these. Just copy that, paste it here. Didn't need to know a head side height either, if I'm going to write this in. Head side height. I need to know that. So that was S. 0.4. So I'll say that's 0.45. That's one dimension I need. And then I added 2 more rows here, right? And they only apply to this fastener as well. So I'm just going to take the same thing I copied. It's not going to, well, let me tell what it is. It's, we can call it whatever it calls it from this chart. You can say that it's the hex size and the key engage. Sure, it matches. That terminology matches this chart a little bit better. So I'll say hex size and key engage. And so that's kind of like the depth of the tool. But so I've added those 2 rows. So I might say hex size, which is, you wouldn't know what that meant unless you're looking at that chart. And then the key engage. If I can spell engage. What? E? Wait. I'm glad I don't teach a spelling class. E-N-G-A-G-E. Yeah, E-N-G-A-G. That's correct. That's a weird word. I guess I'm not. Yeah, okay, I did spell that. Let me go back to grade school without spelling. Yeah, I'm glad I don't teach spelling. Math is hard. If I would teach English. But however, these don't apply. This stuff doesn't. These rows that I've applied or have added, they don't apply to these fasteners. They only apply to this fastener. So essentially, I just kind of shorted you guys. I need to remember that's a major red line I need to make because there's a few rows missing for some of this stuff that I put on my key. But So the hex size for a half inch, I'm gonna go to this thing and find it. The hex size, that's gonna be my width across the flats. J. So J is 0.379. So I'll add that to my chart here. This one, that's 0.379. And then I need to know that key engage or the depth of how deep it goes in. The front view is where I'll need to show that. So it'll be hidden line work for sure in the front view, but I think I'll still show it. So it is this measuring engage 0.245. Yeah, 0.24. Okay. Okay, now I'm ready to go. You watching the video? There's half the answer. So let's draw this. I'll draw. I'll start it from the center. I think that's a good place to start it. Maybe I'll start it with maybe I'll do that X head. Maybe I'll start it from where the last little bit of data we got. So I'm gonna draw a polygon. It's a hex head, so that the Allen wrenches are generally six-sided, just kind of like they are with the bolt and hex head. So six is my number that I use. Yeah, so six is my number of sides. And I will draw this one from center here, and then I'm going to draw that inscribed in a circle or circumscribed. I think I would like this one better because it's the dimension that's the width across the flats, right? So I'm choosing hex. Which one do I choose? Polygon, six sides. So polygon, six sides. So I just hit enter. This is my center. I'm choosing circumscribed about a circle because that will be it'll essentially be the rate. It'll be half of my width across the flats dimension. If I choose the inscribed, I'll need to know the width across the points. I really didn't figure that out. So definitely I'm going to choose this one, circumscribed about a circle. I think I ended up positioning this way because you could position it either way. It's just whatever is going to project down. I do think that this is easier to draw the front view when it's projected this way, just like it was in the bolt head situation. It's going to be hidden line work, but in the front view on this one. But this because this is the tool engage. And so what I need to know is from my chart here, that width across the flats, which is that hex size that we put in here somewhere. Wait, where's my chart? Oh, it's over here on my paper. So I need to know this. This hex size was the width across the flats. I'm just going to divide that in half because I'm the way this polygon command draws, it kind of draws by half of that. 0.379 by is that what it ends up being? 0.379 and a half? Yeah. I have 0.1895. Oh, head diameter. So yeah, if you have to take off, that's fine. I understand. But I'm going to keep drawing this till I finish everything. But I will post it later today. And so even if you haven't finished this, you got to go over the weekend. If you come back into it, I'll have it posted for sure. So I'm gonna do this start to finish. I know it's going to take me probably another. I probably should stop this video and start another one because it's probably going to take me another 45 minutes at least. But maybe I'll try to look through it pretty quick. If you did go wrong, maybe you can see where you went wrong. Watching here, but diameter, head diameter. I need this 0.75. So that over here, put that in off the same center as where the tool engages. This is a 0.75. That's 0.375. That's at least the head diameter plus the tool. I know that I'll have another circle that'll just kind of be that relief in the edge, that chamfer. But I'll pull that from the top or from the front view. So I'm going to project down that. Around this, project down my head diameter. It only goes down to that. Eventually, I'll probably need all this data to come down, but maybe I'll just worry about the actual overall head. It'll look like a rectangle here if I know the head height. I'm going to at least start drawing head. I'm going to draw a visible, like all these heads, it'll be a visible line across the surface. I like that. I'm going to offset that head height. Head height, the main overall head height here, 0.5 is the first offset. Then I'm going to do the side head height at 0.5. So I'm going to offset this two times these different dimensions right here. About set mine first by 0.5. And then again, I'm going to offset by 0.8. That's doesn't give me an angle. I think I'm just going to do that because I don't have like a. Does it give me an angle on that sheet? Oh, that's cool. This one here. Oh, 45. So it's also just a 45. Good. Cool. I'm glad of that. That's what's going to be critical to like project up, but I can finish that. Have 45 selected maybe. Like that's going to be here up. That's the way I see that. It's 45 here. That's what I got locked in there. 4590 is about rimmed out. It's That's what I can do. If I want to finish my top view, I think the last thing is just those. That's that inner circle right there. If I just project up one, that's technically all I need. If I draw that by radius, pull that from there out. Kind of a finished top view. And finishing the bolt here will be pretty easy, just the major and minor diameters, but maybe I'll focus on the hidden view of what that would look like. Um, it's yeah, I'll do it. Maybe I'll start with the overall depth of how that view will be. So because I could offset something like this for that depth from the top surface down, because we have that on our chart. So there's no, I mean, you could start this anyway, but I'll start how deep that key engages is 0.245. So that's kind of the depth of that hex profile that's inset here, 2.45. So I'm going to offset this at 0.245. That's going to be, I'll just make that visible, or sorry, uh, construction work. Maybe I'll just extend it so it's all the way. It doesn't have to be. That's how deep this will go. So maybe this is if I'm projecting from these down, that's as deep as I really have to project them to kind of build. I think I made it kind of the same way. It's going to be, or maybe I just did it just straight line. I can't remember what it looks like. Let me look at my little my cheat sheet here. I don't know how crazy detailed. Oh, yeah. So I just did that, and then I did this little depth because there would be a relief here. That tool, I guess generally when you have a tool that's in set like this, they machine a little relief in here. Um, this is probably a little bit exaggerated looking than it might really be. It might just be a very slight relief in the bottom of that to accept the tool. It's really just probably relief for the cutting of that. The tooling they used to cut that in there probably left a little bit of a relief, like a little bit cut beyond. And so I don't know if that's really shown on this as well. Not so much. So let me draw it in as if it was like just rectangular, but with hidden line work, and then I'll worry about the relief in a minute. So I'm just going to project that stuff down, just the points essentially. So at least that depth. Not like I would build the hex head over here. I'm going to project all of these down. So it's kind of the foreshortened surface of the tool engagement here. And this is the front surface. So these are going to become hidden lines. I think I just put in a depth here of no particular kind of a relief depth. And so that might, how much on the construction layer, it might look like, I don't really feel like there's any super critical like dimension, but this little triangle on the bottom is just that relief that might be cut by a machine essentially. So if I just choose, I don't know what, like 1530s, what does that look like? If it's 15-degree relief, maybe that's sufficient like this. That's like a 15-degree. That's just me saying, oh, it's going to kind of be cut like that. This is going to become hidden line work. This kind of relief in where the tool was cut. These would be hidden lines, and I think so. I'm just going to trace over them with hidden lines. I don't think I ended up doing like the same type of a hex finish like this. I think I just did them as hidden lines like this. Kind of trace this profile. I did, and that's just something I just randomly picked it because it looks good to me. So it's like drafter selection there. I think I kind of did something like this. But that's like 15 degrees. And it's nothing is given there, I don't think, explicitly here. They don't really even show it exactly like that. I mean, so I'm kind of, I mean, they've kind of showed it as almost like they've done this partial section to kind of expose that, but really it would look pretty much rectangular if it didn't have just a little bit of a relief. They've almost done theirs as almost more of like an arc, which is fine. I feel like it's just a small detail that doesn't matter. It kind of looks almost like a drill point here on mine. Because if you were to drill down with a drill, the drills are not exactly 15 degrees, but they're pointed like this. They are a specific degree, by the way, but the way drills are actually shaped. But it'd be more of a broach. Yeah, it's a different. It's not actually a drill. It's not like a center circle. Yeah, the way they cut this. Yeah, they cut it out in chunks. Probably the way they do this. I'd have to watch a fastener into there. I wonder how that's. I can't say I've watched how it's made fasteners, but I guarantee there's a YouTube out there, and I'm probably going to watch it this weekend. Now I'm interested. Definitely a way they cut those in for that. Yeah, is what it's called. Yeah, that's cool. But it would maybe technically have a little relief there. Anything they're going to cut into something like that, it kind of has to have like a little bit of a relief pocket below it. And if I were to pass it around, you'd probably see it because I have somebody that kind of a head. Anyway, not super critical. Even if you just drew it rectangular, I get the gist of it, but I just put a little point in the bottom of it. So if I turn that off, what does it look like? Just looks like, well, I haven't finished all my sides. Let's do that. Looks like it's floating in nowhere. I forgot to trace over my sides. There we go. That's more like what it's going to look like. Good enough. Between that view and that, I get the gist of it. What's that? Like right here? Or if you did it points this way? Like, oh no, it would technically it wouldn't really matter to me. Actually, no. Because I could have even drawn this one this way. Like it could have the point here and then these four shortened surfaces. It would just be a little different looking view. I think this one is easier to draw that way, but yeah, it wouldn't matter if you spun this the other way. No, it wouldn't. In in this view, it wouldn't be too hard either because I'm not going to do that intricate nature of the top of it. So it would just be your hidden lines are just being a little different, and that's fine with me. Totally fine. So if you spun that way, no big deal. Yeah, just yeah. Essentially, yeah, you would only have like a center line plus the two outside lines, where I have like the two outside lines plus the other 2 points. So yeah, you just have one line down the middle. Totally fine to me. Not a big deal. I'd leave it that way. But it's not I'm not too concerned about that. So yeah. But I'll finish the rest of it that I am concerned about here. Center line. Something to offset is all I do this for. Maybe I'll just draw it here and then I don't have to worry about. I don't know how long this is, but if I really wanted to be, it's 2 inches long. So technically I could draw this line 2 inches. And I'll extend it later, but that'll be the actual lengths that I need to offset there. This is a 1/2 inch diameter. Is that correct? 1/2 inch diameter. So my major diameter will be 1/4 inch offsets here. I'm going to offset 0.25. That's my major diameter. Match these properties. Major diameter, minor diameter. Let me check that sheet. Minor diameter, right there, minor. 4459. Yeah, I'm gonna divide that in half. That's not what I do in my brain too easy. Hey, 4459 is about what that was, though. Must have been the last thing I figured out. I'll just use the rounded one, divided by 22295, or I could say, yeah, I mean, I could round this up too, but maybe I'll type in that whole dimension. 22295 is my offset, like that. Let's get those minor diameters in. Another fine thread one for sure. Match some properties. I'll match those hidden lines. And then I'll do my offset for the overall bolt length, which was 2, which I kind of already have set here. I could just draw across, but there's my offset to show it. Then at one pitch, I'll just offset at one pitch now. I don't have that. It's a pretty small pitch, if I remember, 0.05. So I'm going to offset the bottom of that same way, 0.05 offset. 45 as well. So I still, well, I'm gonna toggle this on. I've got a lot more. This gets a little busy, easier to miss that for me. I'm looking for 45s. Oh, did I choose the wrong one? Probably. There's 45. Trim. It's pretty good. Extend this thing. I'll need the center line. Yes, and the extension here. This one too. Hold on. Through extend it. That fastener's about done. I'll just put the center mark on the top. I'll use this one. I've been matching all my extensions are 1/4 inch here, so I think on my finished drawing, I just kept them all independent. I didn't pull those all the way across. I mean, I could have done these as, I think I talked about earlier, I could have done these as not center marks, but I'm just going to leave them. I'm not going to pull those through unless I was dimensioning, but they really are independent views of different things. So I'm not going to pull those center lines together. And then we just need a cotter pin here. Heck yes. And I think what I did is I probably just laid out like from this center line of this, I probably just pulled a construction line over and use that as my basis for like where the cotter pin is drawn in here. I think I'll look at my little cheat sheet and see. It doesn't really matter. I did actually. I have forgotten, but I just kind of pulled from center over to be able to start this. And I think it looks like I pulled. I kind of kept my. I think we build this from this out. So let me go to the cotter pin category, and there's the cotter pin. I'll go to my worksheet. So let's look at the side of it. Simpler for sure, right? So we've got this. Should be the last one on this. Yes, right here. We just need a shank diameter, a wire width, a head diameter, and extend prong length. Okay, so these are I'm looking for. Hopefully these make sense with the chart from the appendix, which is the last one, maybe. Is it the last page? Second to last page, or there's a few other. There's some more drawing stuff. Stuff we'll need for group 2 is here actually at the very end. So cotter pin, there it is. Hammerlock type, extended prong, square cut. This is the one I'm going to draw, right? It's a little bit different. But what we've got is, I think this is a big cotter pin too, right? So like in the worksheet given, this is a 3/8 cotter pin. That's the pin diameter. So let me look at my chart and see, and the length of 3.5. But 3/8, let me see. 3/8 down here, top row of this last 3/8 nominal size. Yeah, so we got total shank diameter. That's A, so it's just whole diameter. Max and min, so there's a range there. I'll probably draw to the max size. The wire width. Okay, so they've actually done like a revolved section right here, right? We kind of recognize that from some of our sectioning. They've chosen to like not even show you they've cut a section, but they kind of cut, revolved it. They show you kind of that the profile and section of that. It's kind of cool. It's a use of that concept there is like cut, revolve, be able to dimension that on top of it, which is kind of a cool concept. And so we've got that wire width, and we've got a head diameter. So that's C, that's the overall diameter. And extended prong length is 16. So that's just a little bit. They're always offset like that, so you can kind of grab them and yeah, and split them if you have to, force them together. They're not necessarily made to hold a load at all. Like a cotter pin is just to usually keep other fastener parts in position and doing their job. Like the cotter pin just kind of prevents like maybe a fastener from falling off or backing off or so really it's not like it's almost just something to keep stuff in position, and it's not really designed to hold like a lot of like weight or they shear off pretty easy if if a load gets applied. They're just pieces of wire. And so really they're just a keeper and they're not designed to hold a lot of strength involved. Whatever's supposed to hold the load is what this is keeping in place and trying to prevent it from being lost or something. But yeah, different reasons, I guess. But and people reuse these over and over. And really, if you probably looked at the specs on a cotter pin, they'd say once you've used it and it's locked something in place, sometimes the way we keep it to lock it in place is we might slightly bend one of them so that it can't fall. Like it gets inserted through a hole, and then we sometimes like will bend where these break away from each other. We might choose to like bend them slightly so they don't so the cotter pin can't fall out of the hole that it slid into. But when you do that, you're kind of like it's not a very. I mean, you're weakening it in some ways, and so cotter pins are generally designed to be kind of one-time use. And if you go to like reuse them again, you should be getting a new one. However, they always get reused, and they're really weak at that point. So a nail that's bent. That's yeah, we would never go and find the right cotter pin, but we have a nail on hand. Let's use that as a cotter pin, bend it. So yeah, and that kind of works because cotter pin, yeah, it'll work. And if you've grown up with farmers, it's a farm fix. I've done it myself. I've reused my cotter pins over and over again too, which is also no, but yeah. Anyway, they're kind of designed to be a disposable one-time use. There is hardware that is really, I mean, that is really its engineered design. It's probably to be tossed away when removed and reinserted with a new one. We just don't use it. We just don't believe that engineers are telling us the truth, I guess, when they really are. We feel like that's perfectly good. Look, it's only been used 40 times. Still can bend it back into straight. Anyway, long story short, they are disposable pieces of fastener, meant to be usually thrown away when removed. Let me see. So I don't know if I have all of these categories on my maybe I'll split screen mine for just a minute while I finish this. So I can read. But things I need to know are the shank diameter. So let me see. They call this the shank diameter A. So A on mine, the shank diameter for a 3/8 cotter pin. I'll just use the large size. 335 is what I'll say. So 0.335, I'll call my shank diameter. The wire width, so that's going to be the B dimension. The on the large size, I'll say it's the same. It kind of matches the shank diameter, 0.335. We could use either one really. Then I need the head diameter. Sure, that's this overall head diameter, C. So 3/16 C head diameter, 0.75. That's what I mean. It's a large cotter pin, a 3/4 inch head diameter on a cotter pin. It's pretty big. And then the extended prong length, this little weird dimension, how far they're offset from each other. So that's D is 3/8 of the nail. Oh, wait, right here, 0.16. That makes sense. 0.16. It looks like I didn't put in the gauge hole diameter, but I did use everything else. So let's go see if I can draw this. I think I just drew it kind of from the center head out. I think I kind of drew this one. Then maybe I drew this A diameter here and split it down the middle. I don't think I show a gap in mine. Let me check this real quick. I think I just kind of show mine like perfectly together, even though like the way they show it on that chart is to put a gap. I didn't. I probably offset this line, kind of that gauge diameter, or yeah, that gauge diameter. Put that little jog in it. Then I kind of probably just did like a tangent to tangent here. I think I used some whatever, kind of like I did with this bottom. I just put it in. So here, I think I ended up like offsetting the wire thickness. Like anyway, I think we'll piece this together, but I can't remember exactly how I did it. But you can kind of see what I've done is I've done a circle and then kind of a tangent to tangent back to here. So maybe we can just use some of our tangent to tangent functions of a circle to create these radiuses here. Because it's not explicitly given to us in the chart. We're gonna hit the dimensions they do give us, but and so then it will represent a cotter pin. But yeah, maybe it's not exactly an exact representation of it. Just kind of a shorthand look. So let's do that. So I feel like I'll start with the head diameter. So I'll pull my worksheet over to my other screen here. I'm gonna start with the head diameter, which I think is 3/4 of an inch. Yep, so I'll put me a circle. think I ended up just using in line with this, and that. So this set right here. And I'm by radius, so half of 3/4 is 3/8. I think you said mine. That's the overall. And then from there, and I think I put a center line on here, so I think I'll use center line again to do some offsetting from. So I'm gonna draw a center line this way, uh, just some unknown distance. I'll trim everything to fit here. So I'm just gonna use this to offset the it's the y it's the look at this. It's gonna be I want to know this kind of that A dimension is 0.335. So I'm just going to do half of 0.335. So I'm going to offset 0.335 divided by 2, 1.1675. I'm going to offset 1675. Right. It's going to be visible line work here. Kind of what it looks like, really. And then I think I offset that same distance here because it's kind of like that same thickness of material is what I would have here. So I feel like I used that same offset. So I just kept it again. And then I offset this the same amount like that. I think is how I did this. Essentially, I just need to like turn this around so they fit. So it's kind of like a tangent to tangent here, maybe. Radius and a tangent to tangent here. So we got to draw that in. I'll just do it on the visible layer, but I think I could do that kind of in a circle, right? Like a tangent, tangent, radius. I don't think it really, I probably just picked some random thing where I went tangent, tangent. The radius is 3/4. Does that work? Yeah, probably. That's just 0.375 was what I had like loaded for some reason, or maybe it was 335 actually, probably was. I feel like I could almost use any dimension here because I'm just not giving it. All I want to do is show a sweep here and a sweep here to this, and then I'll trim everything. So I feel like we have a lot of leeway on how that's going to look. I'm just looking for the imagery of it, so I'm gonna say tangent, 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 tangent. 375 is what I have. For some reason, it must be in the last circle that I drew. I think it was. I think it was this diameter. So maybe I'll just use that. It's like a 375. I mean, I could do some mirroring or whatever. I could just redo that. What does it look like if I do that here? I do like a tangent to tangent at the same. Kind of looks like that. I know this gets a little busy, but maybe I'll finish cutting this, trimming this so I can make sense out of it. But just look at the outer one. That means that this is going to get trimmed. This is going to get trimmed. Plus, I've got some overlapping here, and this will get trimmed. Then this is going to trim out too. So that's kind of what that sweep looks like. I'll do one little thing is I'm going to draw over the top of my center line with a visible line, then I'm going to trim. So I'm going to draw this one pretty much over the top of my center line, kind of bury it, but I'm going to use it to trim this. Trim this, trim out this. This is not what I needed either. This isn't what I needed, and I don't need this as well. So now I've been able to kind of make this sweep back into that line. That's some random radius essentially. So maybe I will just like get rid of this from it. Maybe I will mirror this across. So I'm going to mirror this little arc here, this little arc here. I'll just mirror those across this line. No, I don't want to do it. Now I have little less to trim, I guess. Still got this and I keep track of it. That's one way to do it though, right? That's one way. Like I said, I didn't worry about the gap in between them. I just kept them that overall kind of shape, but middle wire. And then I just need to do this the length the length we call out on this, I'm looking at my worksheet again. We called it a 3.5 inch. I think that's the overall, and then the little extrusion goes out past that this far. So where that is, well, that's kind of let me see. I don't think our chart really shows. Yeah, oh, it does show. Length is kind of going to be where those maybe where that tangent to tangent point is, or maybe it's a little unclear, but the length is going to be the short side, then we're going to extend that other one past. So where this is, oh, I don't know. It's like, it's kind of critical, but I think if I said if I was on a construction layer and I'm looking for something that I could snap to here, it's in relation. Is it here? Is it here? This is kind of the midpoint of the arc. Maybe I just chose here. It's that's just me like looking at like looks like they're kind of choosing not exactly where they go tangent to straight. It looks like it's back in a little bit, but I don't know where. Somewhere in that area.
Some sort of gauge type.
Oh yeah, the plane of contact with gauge, huh? Gauge, yeah. Plane of contact with gauge. And really they're calling, I mean, they really would think of the gauge hole diameter. Yeah. I'm gonna pick any point on here. Because all we're drawing is something that's close to it. Don't scale my drawings. I think what I ended up picking is probably like the midpoint of that outside arc. That's kind of where the base might. There's a midpoint there. But I chose something like this probably is where I'm basing my length off of. So if I offset that, the length of this thing to the shortest one is the length that's given here, 3.5 inches long. So it's kind of long. So I'm going to offset that point wherever you chose to draw maybe a construction line down or some type of place to base this off of. I'll offset it that 3.5 inches. And I'm going to use that as my offset feature. So it's a little bit longer than I've taken everything to for sure. Maybe I'll extend these a little bit if I try not to pull them off. I'm just going to use that so I can extend my visible line out there, this visible line. Really, I'm going to extend the center line too. Hold on a minute. I'm going to pull this in past just before I lose it. I'm going to extend that one. I'm going to extend this one. And it's going to go a little bit further even. So now I'm going to offset this one more time for that prong extension, which is just, we have it on our chart here, right? This extended prong length, 0.16. So I'm going to do one more 0.16. Sorry, let me get my number here. That. Now I feel like I can do another extend. And then I can draw this in on visible line layer, I think. This will come up like this, jog like this. I think that's it. If I turn off my construction layer, I think I put some center lines on here though, so I want to extend those out. I'll probably try to bring them to front here, just so I could see it like that. I know that the visible line will take precedence in the plot style for sure, but I'm gonna pull this one through here 1/4 inch. I didn't. I'm gonna make sure this one maybe extends past a 1/4 inch. I think I put one vertical there. Did I? Probably should have if I didn't. Yeah, I did. I put a vertical in there. I just used I think just a simple line though. I didn't do a center mark. Since I already have a center line, I think I just went in here on my center layer. Put a line in here from quadrant. Quadrant. That I think I called that almost done. I'm ready to go to my sheet though. No, I'm gonna finish this as one big major video that's 2 hours plus long. Part three is what it'll end up being. Okay, so I'm happy with this. I'm just gonna put on a B-size sheet for sure. So here's my B-size sheet. I've got all my different sizes. This is the only one I'm gonna use though, I think. Click in here, let me find it. There they are. From what I remember, I think 1:1 for me was just a little bit too big. 1:1 on this. Just didn't feel like I quite. I'll click out here and take a look, but I feel like, and I hate these. I do hate those viewports. I'm going to add a new viewport. So I just want like a simple that thing, but maybe in this. course, I would have loved to have a layer. That's easy enough. So I think what I found out here is that one to one's just too big. I just don't have quite enough viewport room to do that. So I think I ended up going three-quarter size. So I had to make a custom scale. I mean, half size would work. Like I'm not, maybe it's just a little bit small. Sorry, I'm gonna go to half size. It's the next one I would have options to. Yeah, it would probably work. Like it's definitely, B-size sheets are big anyway. So if you do a half size scale, I think that's fine. I'll go ahead and do mine as a three-quarter inch scale. If you forget how to do that, remember it's just click your scales, go to a custom. I'm going to add a, they don't have a three-quarter scale. I'm just going to call it exactly that, a three-quarter scale, 3 to 4. Save them up. Paper units are 0.75 or three. You can put 3/4. I think you can use fractions there too. Okay. It doesn't allow you to apply it until you say okay, and then it adds it to your list. Now I can apply that. So I think that's what I use. Maybe it fit just a little bit nicer. So yeah, if you guys are taking off, have a good weekend. See you next week. See, got some line type scales to adjust. I can tell super coarse on the hidden line and the center line. So I'll worry about that in a minute. I'm gonna go into this viewport and start labeling it. So I've chosen that. I'm gonna lock down that viewport. I'm just gonna label these with a view label. So I'm gonna do that within my viewport. I'm gonna add some text. So I'm gonna add this to my text layer. Text and multi-line text. So I'm just going to label these anywhere on them, right over the top. You could label the top views. You could label the front views. Maybe I'll just label my top views. And maybe I'll just label these right over the top of them. You could put them anywhere though. So I'll just say, here's going to be my first text. Maybe I'll center justify, but you don't have to because you won't be able to tell. But I think we just label these as letters. I can't remember I'll just do. I can check this real quick. I'll check my worksheet. Maybe they already gave me something to work with, but I don't. It wouldn't matter as long as I just keep track of it. Yeah, they did go A, B, C, D, E, F, and they placed it down here in the front view. Either that doesn't matter to me as long as I've got it. As long as I've got my views labeled. So A through G is what I got to label. Okay. Oh, that I'll call that A. I'll move this down a little bit. Well, it's got a clear label. That's good. Hey, I'm just gonna copy that over. I think I'll just copy that. Copy this thing. But oh yeah, that's a good question. That should probably be what do we do on our that's a good question. I think these can be I think these are regular size. I think that is a regular size font. If my dimensions were there, I think they would match. So point 125 font. Yeah, that's a good question. And that's what I think that's what I placed because that's what I had loaded in my is my ASME 1/8 inch text. So that's what I mean. I use the larger site text when it's a view label for sure, when I'm actually giving it a title or a heading of my or a title of my view. That's large size. I use those, but I think our metering block and the gasket, I'm pretty sure we just use regular size text. Those are pretty small parts, so they would have been huge if the text wasn't. So this I think this looks yeah, good question. Copy that. If my people had issues like reading my print, I might break my rule and say, okay, I'll make my stuff, I'll make my view labels bigger or my feature labels. You copy this thing. That where anyway. Let's see. It's got this note out here that I really can't grab without pointing to. So I'll just put these at the top of them. This one's going to have one. B, C, D, A, B, C, D, E, F, G. It's funny. I don't think we must not put the nut on there. I have to see what my table looks like because the nut is really its own feature. Um, surprise, or maybe it's part of the assembly. So the thing is that yeah, my table can be the fastener and the nut combo in that column. I actually don't know if that's what I got. Let me fix my labels here real quick. It's B. See, yeah, that must have been what I did too. But so there's those. That's really all I need here. I just need a table to classify those. So maybe that's the simplest. You could have done local notes though, right? Like another way on some drawings, if you have maybe minimal fasteners, it would be fine to me. I'd be maybe be on my text layer here to go to your annotate tab and say a multi-leader. I know we don't use these a lot, but it's funny we will start using them. But technically, I could have said, oh, this particular fastener, and what I would call out here it would be the thread note. So what would go in here if you're going to label them this way would be our thread notes for A. I'm going to go back to my worksheet and look it up here. It's actually this is what's going to be there. Thread note for A would be a 3/8-16 UNC-2A. Technically, I could maybe copy this. It's maybe got italics fonts, but I think I could copy this, go into here, and just say paste this in here. We just want to highlight it and make sure it's not mine's italics, but this would be a totally fine way to actually label these on the drawing, right? And then you'd come back in here and I have to label each one, make sure I adjust that so that it all fit. You could have individual, what we call like local notes, right? A local call out. I'm going to build the table. Maybe I like it. It's just a little cleaner. I feel like fasteners in general and assemblies fall under the table. Like I'll have a call out that shows it's kind of like I've done. Just have a label next to it. One other thing I'll note is that let's see here. I'll go back into this report real quick because I'm actually not going to choose to do this. But usually the other thing that's pretty common that I'm not doing here is these sometimes end up in what we call as a balloon. You're probably used to this from the architectural days or whatever. But generally, when I have like just like a feature label, sometimes it ends up in a balloon with an arrow with a balloon, and we haven't done that here. But that might be another thing you might see on a lot of drawings is instead of and I think I can change my multi-leader to be a balloon. If I really go into the modify, I might be able to like put change it into like a balloon. I have to see. I have to dig through this a little bit. Um, I know we didn't on our other, and it could be that if I select that, do I have like if I have my properties table up, I get a lot of other options on changing the arrowhead size. I feel like I can also put it in a box for sure. But I'd have to look through I would have to like here's the text frame. If I said yes, it just builds a box. It's not exactly what I want. It might be more of a balloon with the letter in a balloon if I was going to do it. So I just wanted to say that when we get into assembly drawings, we'll start to point to our features as a ballooned item on our prints, and then those ballooned items will end up in a table generally to explain what they are. So that's going to be probably my common go-to when we go to a 3D program for sure. I feel like it's just more built in on a 3D program that's just how their their feature labels are kind of ballooned to add like if you have a parts list. Not to say I couldn't do that here or create one myself or create a block. There might be a block that already exists that I could use for that. But I'm just going to go with what they did and just put my view label next to my part. I'm not going to do this one, even though it's possible. I'm going to go to a table. So let's do that. Table here. Looks like I've got 1, 2, 3, 4, 5. What? 1, 2, 3, 4, 5, 7. So I need a table at least carries 7. What it's going to like if I think ahead, if I'm not even looking at what I did before, but really if I do this in my mind, I'm thinking, well, what would I need to what information would I need to know in my table? Well, I would probably need to know it's like sometimes I'll just take a piece of paper. I'll be like, it is going to have a table that my columns might be um for sure that view label. So I'm going to need to know like that feature label or whatever we might call that, like fastener. So the fastener, which my column might say fastener, and then it might be like A, B, C, D, E, F, G. That's what's going to go in maybe that column. Whether fastener is the header or not, I don't know, but fastener. And then I'm going to need to know the thread note. So I'm going to need to kind of know its description. You could probably even say description or thread note, but maybe that's going to be a column that says description. Maybe I'm going to want to know its length. So the thread note might not include the length. Maybe length is going to be in its own column. And then maybe I would want to know quantity. And that's give or take. We know here the quantity is just one, but QTY. So I could see that I probably need four columns maybe to describe this. That's just me. And now I'll look at my cheater and see what I did here. It looks like I did five columns, one, two, three, four, five. So I have the label. Okay, so I call this label. Then I said type, which you could say, oh, so I get it. I've kind of said like what kind of a fastener is that? That's kind of helpful to know actually. So type is I think I will keep type. And then I'll have my thread note and then the length and the quantity. So I was pretty close. Maybe I'm just feeling like, and sometimes if I do my tables wrong, by the time I'm building them, I might be like, oh, I want to make sure that people know that that's that type. Maybe it's obvious from the picture what it is, which is helpful. So maybe type is maybe not necessary if people can identify that. Maybe a young drafter or somebody new to the industry might not know what that is. They can visually see that obviously they're not all the same, but what is that called? Well, would you know that that's called like a Philister head cap screw? Probably not. That might be a new term that you'd never have known until now. Even if you'd see this view, you'd be like, well, I don't know what that's called. Well, it's a Philister head cap screw. So I do like this almost as a training purpose for us to be able to capture what those were. So I'm gonna build my table this way. Maybe I'll just take a quick little image of it. Of course, mine's upside down, backwards, but I keep it that way. So I'm gonna do that again. Here we go, table. So I'm gonna get my table. I'm going to insert it on my text layer, I think, too. So my tables are in red. I didn't drop it yet. No, but here's my table. I'm on my text layer. Here's my table. So I decided I'm going to do five columns, I guess. Even though I say quantity, I could maybe drop. That's okay. How many rows do I need? Well, it looks like I've got how many of those A through G? Seven. And it's okay if I don't choose this right at first anyway, because I'm going to do a little manipulation here. I'm not going to give my stuff a title. Um, if it was a title, maybe it'd be fasteners or something. But I'll switch my title to just be the header, and I'll switch my header to be data. So then I've got all this data and one, two. So I probably have too many rows now that I've switched that up. But I'll say okay, and I'll still keep mine drawing from the bottom up. So I'll say, yep, I like it. It's going to go over here. I don't usually size it till I put all the data in. So I just drop it over here. And then I'm going to go in here and start putting in my data with my headers first for me. So I think we just did label or, yeah, label works fine. Label. And then we had, maybe I'll just say description. I have a big word I could use. I think that's shorthand is descript. Let's check this. There's probably a correct acronym for description. Google it real quick. Description. Oh, DESC is really the easiest. DESC is probably the smallest column I can make. DESC is description. See, yeah, see, okay. Label, description, thread note. I'm going to say this is thread note though. Length. What's length has a abbreviation too, I think. Yeah, see, length. LEN. You want to do that? I already have red notice kind of. Yeah, I'll fix these if I feel like I don't have room. What really will make me usually abbreviate is once I'm like, oh, I don't have room to write that, and my table is going to be too long given my. But I could put them on the next line too. I could condense this just by making it a multi-line header. So, and then quantity QTY is really the common for quantity. So, okay, so that's that. Now I've got labels. What do I got? I just got A through A, B, C. EFG. So I definitely have one extra line. If I need to modify that, remember, I just go ahead to these like rows and it kind of changes my, what's that whole row? Let's delete it. If I need to delete a column or add a column, come here, add or delete, drive them from your A, B, C's, one, two, threes. So there's that. The description of A. I can probably copy and paste this from so maybe I'll do that. Maybe I'll bring up my worksheet. I know that it'll be italicized. There, technically I have them. There's A's thread note. That's the last thing I'll copy and paste this in. I don't have to rewrite it. I won't. That's the description for A. Like, I don't even think it came in italicized, so it must have like reformatted itself. Oh, to be my type of text, I think is what drove that to change. So that's that. That's A's description. B's description. This one. That's the wrong description. Sorry, that's going to be thread note, by the way. So I'm going to copy that and move this in here. I'm going to delete that out. Description is going to be. I might have it on my chart, but I'll keep doing all my thread notes. A, B, C. So I'm going to do. Yeah, here's. Well, go ahead. It's not corrected to the table. A whole row went into the side. It's almost like it's a separate whole table. Yeah. Oh, let's see. Is it because your table doesn't have enough room to fit it? And I don't know. Let me look at that actually. I think I've done that. I think I've done that before. I think I've had that issue before. I can't remember why. I feel like it's like oh, put it over there. I don't know how do you put it back. And then, then it'll add over there. I don't know. Let me do a little. Let me see if I can mess mine up and fix it real quick. I push pause on my recording anyway. Let me see. Let me see. They're kind of weird tables for sure. So how you even did that? It's like a split table now, huh? Let's see. Let's look at my properties table, see if there's anything. Rows, heights, alignment, middle center, cell locking, unlock. Let me see what the properties of adjacent table. Select that. So we see direction of enable table break. So mine say it's not enabled to break. So what I'm looking at is if you have your properties panel up, then maybe this is it. If I select just my overall table, it seems like we've enabled a table break here. So if I say yes, then I have that little arrow, and I feel like, is that what it is? It's the enabled function, huh? So if I disable that, it links it back up. Yeah. Okay. Cool. Yeah. Yeah. It's definitely a property. So when in doubt, find the properties of that feature. It goes to show that. I mean, that's why I'm so used to having my properties up, because it seems like it has all this control that I forget what I can really do. Yeah. That can be handy, obviously, when you are to break it up and be able to, if you've got more linear length on your drawing to fit your table. I mean, some drawings need some pretty extensive part lists, and it does help that they don't aren't this huge, like, long list. There better be like a horizontal table. So I've done it in Inventor more like that. So I do. The brilliance of that especially on a B-side sheet. Sometimes you have a lot more linear length than you do like up in horizontal length. So, or the other way. Sorry. Sometimes you don't have as much vertical length for the table as you do kind of like that horizontal length. So having a table break is a good feature. Okay. So I'm just copying and pasting this in from. in my drawing. So maybe I'll split my window of my CAD. That over to there, and I'll bring up my. I'm just copy pasting and bring here. So that's A, B. Here's C data. Back. If I have a worksheet to work from, I'll try to copy paste that stuff. Cotter pin. I don't remember what I put for the cotter pin. If I just said cotter pin, that seems like it's more of like a description. Let me see what the do I use for. It's just a cotter pin is what I use as the type, I guess. And the thread note was just 3/8. I guess that makes sense. Just a 3/8 size cotter pin. That makes sense. It's kind of a weird, um, maybe one that's not super obvious. That the thread note would just be at 3/8. It's it's wanting to push that to the side. That's fine too. I'll show you how to fix that. I don't worry about that till the end either. Until I'm just kind of fixing my table for my data. One thing that's going to annoy me a little bit is generally we're all capital letters when we label stuff. So this coming in, I wish there was a quick way to just say don't. But I'm probably going to rewrite this in all caps, which look, I don't know. Maybe I'm not going to be super critical on that because if you're just going to copy paste like I am, it's going to be easiest to all these descriptions are written on our, but you're going to have to, but they're going to be in small. So this is a flathead cap screw. I think I'll be okay with this copy. For A, this is the description, flathead cap screw. It'll just not be all caps. I would say in my tables, sometimes that happens, especially if sometimes what ends up in tables in Inventor when we start to go there will be what shows up is how it's been categorized or cataloged maybe in the library. And so and I would see sometimes I'd have a mix of people with small letters in their tables. So I don't think it's the end of it. Roundhead is pretty common when people made library parts. And I feel like fasteners end up as library parts in most design groups. However somebody entered that data is usually how it's going to come out. And I did see mix and match happens, which is slow case. But D is this one. Head cap screw. Oh yeah, and this is what captures that. You're right. Copy. If I have E labeled as this as a description, so I'm going to be getting that box. Hex cap screw with hex nut, 1/8. It would be enough to without yeah, I'm kind of classifying that as an assembly there. So that works. Otherwise I should have if I don't love that, I think I should label them differently actually, but it's a stop with head cap screw. Good. I need to know those lengths too, so go back up to A. It needs to just be enter 2, and this one is 2 1/4. For B and C was 2.5. It's gonna looks like it's gonna populate 4 decimal places. So I'll show how to we'll reformat that a little bit. Let's ABC. Let me go down here. 1 3/4. And remember, I use my arrow keys a lot to drag around instead. So it's, what we've done 2.5. Got a 2. And the length of this one we consider 3. We didn't have the length. The quantities were all 1. And then let's I talk about like refining my table here a little bit. So I'll go back to this. Look, I've got all my data in. Yes. Also, I did. I just called it 3/8 as a thread nose. Yeah. That's kind of a little bit misleading, but yeah, I think at least it has its generous size and its length. 3/8 cotter. And that's kind of how we call it. We'd say it's a 3/8 cotter pin, 3.5 inches long. That's probably all you would need to know to pick it out of a drawer. So what I'm going to do is I'm just going to center justify. Like a lot of, I say I don't really have a standard per se, an ISU standard. And so if you left it like this, you'll see a lot of places they're fine with their data. I wouldn't love this one where they're not the same. So I want to push it one way or the other. So I'm going to center justify all of mine. So if I just select my table, select all of the column, this is the alignment tab. I think this changes whether you're in one and it's like this is how the center justify panel looks. But if you're choosing all of the columns or rows together, it kind of looks like this. Kind of strange little imagery there, but I'm going to say that it's middle center. That's going to push everything. It's just because I think the default, and I think I've brought this up every time I've used the table, the default data is letters centered, numbers hard justified one way or the other. It looks like either right justified, but that's deep. So I'm just going to override that. The other thing, so I'm going to do that here too. For this column, I'll make it center justified. But I don't like the data having all those decimals. So I'm going to say drop the leading decimals. So I'm going to come in here. I think I'm just going to select not the header, but just these. I'm going to select all the data from my table. And I'm going to change the data format. So data format has this really, I'm talking about like decimal numbers is what I really want to change. Decimal numbers. Well, that's not it. Oh, I want to say custom table. So they gotta choose here. Here's another dialog box for decimals. What I want to do is additional formatting here. Another dialog box. Jeez. Buried in here, but there's this drop this trailing zeros is what I want. I don't need to have all these trailing zeros. So I'm going to say, okay, I could technically drop the leading zeros, but I think if I just drop the trailing for these, see ya. Yes. Then I get these like pretty common numbers that are the zeros or drop all my zeros. Yeah, exactly. So I'm going to select this again, and then I go to that table format, and then I go to the custom table cell format. Oh yeah, I'm back one up. This is this. So I've first thing I've done is select what I'm going to mess up, which is all this. I just like highlight over it and I got everything except for the title head. I didn't want to mess it up. So I'm just like, okay. Then I go to the drop down on data format. Depending on the data, you can so I've selected decimal number and then custom table cell format. I think these are the same. I don't really think I have to select that or check it from the front. I think I can actually just go to this and make sure I'm looking at decimal number. And then it's this additional format. You don't get a lot of nothing changing there, but additional formatting is where I can start to change the precision for sure. Like if I want to cut down the accuracy, but I drop the trailing zeros here. Yeah. And then when I said okay on that, you end up simplifying the lane. Yeah. And then I'm going to center justify this one too. Now I can size these. So I might individually size these. These two are going to stay wide, but I think so normally when I would size mine, I might come over here and like pick and change them from the properties panel, like their cell widths or whatever. Um, this one I might just choose to individually size each one as small as I can to keep it maybe on this. Once it goes to a double row, I might just see if I can fit single row over on my drawing. But if I need it to be a double row, that's okay. I will. Like this one actually has gone to a double row. And it might need, I mean, it'd be a really wide single row. So I think I'm going to say, oh, I'm going to make that at least one of those cells a double row. This one, that one's about as small as I can get that. These can get quite small, as small as the length can be. That's almost 0.9. I don't think I can go much smaller than that, but essentially like one is the cell width. Then I think I'll make this one match like one. Then I'll make this cell width match. That's that's a reduced. It still might be too big. I don't know. Now that I've kind of got all the data in there, I'm going to see does it fit in here? Yeah, it actually fits pretty good. So even with this, I'll just drop it over the top, and I'm leaving my revision block ready to grow. That actually is going to look pretty good. There's all my data. Just need to fill out. I'm do some last thing I'll do before I fill out my title blocks is I'll just adjust my line type still. So this is not quite fine enough, maybe half as much, even more than that, maybe. There I get the breakup. I think I'm close. I'm it's that's a quarter-inch line type scale for these center marks. That's pretty decent. We'll use that for the center lines as well. Happy with that. Really the hidden lines don't look too bad now that I'm actually at my scale and looking. Maybe they're a little bit fine. I could maybe make them a little finer. It's a small deal, but five, sure. It's one more clip, but I think I went to 0.5 line type scale at my 3/4 scale line. But they were pretty much not too bad either. The only one that wasn't was maybe over here on the plan. Just get those to break up just a little bit. Small detail. Okay. And this one here. That's it. Except for just fill out the information here. It's a B-size sheet. My scale's 3/4 though. I think half scale would have been fine there too. So if we kept it at half scale, I can do it on this day. Your title is that all fits. If it doesn't fit my title block, I'll come up with something else. But that fits. Um, that's all I need to change there. Then I'll fill out my revision. Hit my print preview. There, it looks like my center line's over my visible line. I wouldn't love that if I'm going to zoom in just a little bit, and I will get that I think when it prints, I'll definitely get the line precedence of the visible line over that. So I'll just leave that. I think it'll be okay when it actually prints to paper. If I did, everything else looks all right. Yeah, that's it. I'm going to save that. 11 over. Just Fastener Group 1 in class. I'm just going to copy of my PDF. Good. All right. See you on the next one. This should be the end. It's a long